Okay, yeah, we have talked about, let me go back a little bit. At least leave this for picture. So I forgot to record from the beginning. So what I did is review number 1, number 2, number 3, number 4. So for number 1 and number 4, you see x approaches to a value. In that case, we need to check to see if the denominator is 0 if we plug in -2 into the denominator. Indeed, it costs 0, so we have to use a factoring skill. Okay, so factor, we manufacture a common factor in the numerator and in the denominator. Then they cancel out to be 1. Then we plug in the value. And for 2 and 3, x approaches infinity. In that case, we just use ignore rule. We ignore the lower terms. We only take the leading term into consideration. Leading term means the variable has the highest exponents. So now we're going to talk about 5. But before I talk about 5, I need space. So I'm going to erase everything. All right, you can always go back to watch it. I'm going to erase this. Now let's go back to 5. So 5 is the same thing. If we plug in 1, we get 0 in the denominator. So which means we have to use some gimmicks. And we use this, a minus b times a plus b equals to a squared minus b squared. In our case, you see we have square root of x plus 3 as a minus 2. 2 is b. So we're going to multiply x plus 3a plus b plus 2. In this case, we get a squared x plus 3 square root square minus 2 squared. Square root opposite operations, they cancel each other. So we just get x plus 3. The minus 2 squared, which is a 4. So we get x minus 1. Okay. We get x minus 1. Well, what is x minus 1? X minus 1 can be written as negative 1 minus x. Because the denominator will have 1 minus x. We want to manufacture a common factor. So we just do that, right? So when we do that, so we're taking this just as group, right? So x plus 3 plus 2 divides itself. We basically multiply by 1. And this 1 is square root of x plus 3 plus 2 divides itself. In that case, we get denominator, we still get a 1 minus x. But the numerator, we see from here, we get this, right? We get negative 1 minus x. And the denominator will still have this term. So square root of x plus 3 plus 2. Now these two canceled. Right? The common factor is canceled. So we can plug in 1 now. So we have this negative sign. So keep the negative sign. Right? Basically, it's a negative 1 in the numerator. We'll keep the negative sign. So negative 1, right? This cancel out, has 1 left, negative 1, divided by square root of 1 plus 3 plus 2. Well, negative sign we can put up front. So negative 1 over 1 plus 3, 4. Square root 4 is 2. 2 plus 2, which is negative 1/4. So we use these gimmicks, right? This is called difference of two squares. Anyone has any question? Okay. If you have any question, feel free to stop me at any time, all right? Otherwise, I'll just keep moving forward. Now let's see 6. Six is saying find the equation of the tangent line that pass through, no, find the equation of the line that passed through the point, or given a point that's perpendicular to this line. Well, this line has a slope 2. The line perpendicular to this has a slope of opposite, this is positive, opposite is negative, inverse 1/2. So with this slope, with this point, we can form, right? So y minus -1 equals -½ times x minus 5. Slope point formula. Or you can think I'm using the slope, right? I'm using the point xy and this point. So I get a y minus -1 divided by x minus 5. It'll be the same thing, right? If you remember slope point formula, you plug in this. If you don't, you just use the slope formula, right? Slope equals y minus y1 divided by x minus x1. So treating this point as x1, y1. Then in any case, so y minus -1 becomes y plus 1. Move the 1 to the other side. Becomes -1. So -½ x minus half times -5. That's plus 5/2. Then -1, right? Which give us a y equals -½ x plus 3/2, right? Because 1 is 2/2. Once we have a common denominator 2, do 5 minus 2, which will get 3. So that's it. So that's the line passed through the point 5, -1, and the perpendicular to y equals to 2x plus 3. Okay, now let's see 7. 7, find the points on the curve whose slope is 12. Right? Again, slope. Well, this question has to say whose slope of the tangent line. Right? Missing some words cause confusion of the tangent line. Okay, add the points. Right? Because the curve doesn't have, slope, right? So when we talk about curves, we don't talk about slopes. We talk about derivatives. Slope is only for a line, a straight line. Okay, anyway, so this means the graph somehow looks like this. All right. So the tangent, so the slope equals to 12. Slope of the tangent line equals to 12. Right? You will see we're gonna get 2 points. We're gonna have 2 points. Okay, so how do we get it? So first we're going to find y prime, which is the same thing when we see f prime, but usually y is just f of x. Right? We know f prime. The same thing, we just use y prime to indicate that's the slope. So we get a 3x squared. And the plus 1, well, slope of 1, derivative of 1 is 0, right? Because it's constant, it doesn't change. Derivative means the rate of change. Well, if it's constant, it will never change. So that's why its rate of change is 0. So what we know this is, right, this can be the slope of the tangent line is the same as the prime derivative at the point. Now, given this equals to 12, we divide by 3 on both sides, we get x squared equals to 4. We square root both sides, get a plus minus square root 4, which you get a positive 2 and negative 2, right? Because negative 2 squared also positive 4. So when we square root, we always get positive value and negative value. So which means the x value of this point is negative 2. The point of this one is positive 2. But then we go back to find the y value. We go back to find the y value. Well, the y value equals to 1 cubed plus 1, which is 2, y equals to -1 cube plus 1, which will get 0. So -1 raised by 3 is still -1. -1 plus 1 is 0. So we have -2, 0. Oh, hold on a second. I plug in -1. I have to plug in 2. 2 cube. 2 cube plus 1, that's 9. Right, because my x value is 2 and -2. So plugging into our original function x cubed plus 1. So y equals to 2 raised by 3 plus 1, which is 9. So this is 2 comma 9. And this is -2 cubed plus 1. Well, -2 cubed is a -8 plus 1, which will get -7. So we get -2, -7, get 2 points. All right. We always equal the slope of the tangent line is the derivative of the function at the point. So we use this idea. Anyone has any question? Okay, let's move on. Before I move on, I have to erase all this. But you can always go back to watch it.
Sorry, I have a question.
Yes.
Just like from glancing at the problem, how do you know there's like 2 points like that? I guess 2 curves, like for those
Oh,
two.
because, okay, that's a very good function. That's good, very good question. Because I know this function very well. Let me just give you some idea about functions. Okay, let me find a spot to talk about the function. Let's use this. This is a very good spot. Okay, so those are polynomial functions, right? Polynomial functions either has something x raised by even number. Well, of course, it has some number here, plus some lower terms. So this is called the leading term. The leading term tells us how the graph goes. So let's see x squared. X squared, hopefully we all know x squared graph. It's a parabola, right? You see it's a symmetric. It's a symmetric. However, it's symmetric with y-axis. Symmetric with y-axis. So when we talk about slopes, the different slopes will only have passing through different points. So we know if I'm given a slope, find the points, I will only find 1 point. I won't be able to find 2. But however, if the function is odd number, this is odd, like like a 3, 5, so on and so forth, right? So especially x cubed graph looks like this. And those functions are symmetric with the origin. Well, with some, with 1 point. In this case, with the origin. So they're symmetric in terms of the origin. In that case, there are always 2 points have the same slope. Not always. Some points may not have, like this origin, right? Does that make sense?
Yes, thank you.
Sure. Okay, so 7 and 8, right? 7 is, you see this slope, this degree is odd. Let's see number 8. Number 8 is in given G as, polynomial degree 3, also odd degree. Find the equation of the tangent line to the graph. Same thing, right? 1. And we need to find the point. When x is 1, 1 cube is 1, 1 times 4 is 4. So the point is 1 comma 4. Now we need to take a derivative. So g of x equals to 12x squared. Then we need to find g prime of 1 because we're talking about at 1. At 1. So 12 times 1 squared, which is 1, this is 12. So this is going to be the slope of the tangent line. So now the slope equals 12. We have this point, and then we have the point xy. Is to do y minus 4 divided by x minus 1. Then remember we multiply x minus 1 on both sides. Right? So this one is in the numerator, this one in the denominator. They cancel out. So we just get 12 times x minus 1 equals y minus 4. Because it's an equation, I can write 1 minus 4 on the left-hand side, then 12x minus 12 on the right-hand side. I move negative 4 to the other side, which is a plus 4 to the other side. Or minus 12 plus 4 is minus 8. So that's it. That's the tangent line pass through that point. Right? So which is the graph. You don't need a graph, but the idea is this. Okay. So we're given x equals 1. Let's see, this is 1. We want to find the representation of this tangent line. So we need to find the slope at this point, which is g prime of 1. Then, right, that's the slope. Then we use a point given x value, you can find the y value. So given this point, so in the end, we'll get y equal to 12x minus 8. Okay, let's see 9. 9 is same thing. The only difference is the function is different, right? So let's rewrite y as x squared plus 5 raised by half. And we need to find the g prime. G prime of x equals the half of x squared plus 5. Remember, this is 2 layers. Half minus 1, negative half. Then we have to take a derivative inside. X squared plus 5, which is 2x. So we multiply 2x. Then we need to evaluate at 2, because the x value is given as 2. So we get a half times 2 squared is 4, plus 5, raised by negative half, multiplied by 2 times 2. So this, well, half cancels with 2. So we have 2, we still have this 2, right? Then this goes to denominator. Do you see? So 4 plus 5 equals 9. Then this raised by negative half. Raised by negative half means 1 over square root of 9, which means 1/3. Right? Negative indicates going to the denominator. Half means the square root. So that becomes 2 times 1/3, which is 2/3. Okay, make sense of this? I'll get some water. Any questions?
That's just chain rule, right? Like the
Exactly. That's a chain rule. You have to think there's 2 layers. You have to take care of the exponents. Then you take care of the inside. It's compositional functions. Okay, let's go to 10, but before I go to 10, I need to erase, get some space. Okay, 10, perpendicular, so this is just one more thing, right? Perpendicular to the tangent, to the tangent to the curve. Again, first, whenever we see the word tangent to the curve, we know we need to take derivative. So we get 3x squared plus 9. And we're given this point, right? Now, y prime, so we evaluate at 1. X value equals 1. So we get 3 times 1 squared, which is 1. 3 times 1, 3, plus 9, we get 12. So this is the slope, right? But we cannot use this slope because we want to find the line perpendicular to the tangent line. So we need to get M2. Well, M2 is the opposite inverse of 12. Opposite inverse of 12. So our slope for this is negative 112. So now we do y minus 2 divided by x minus 1 equals to negative 1 over 12. Then again, we multiply x minus 1 on both sides. We get that y minus 2 equals to negative 1 over 12 times x minus 1. We simplify from there. Get a y equals to negative 12x minus 12, 1 over 12 times minus 1 become positive 1 over 12. Then plus 2. Well, 2 can be thought as 24 divided by 12 because we need a common denominator of 12. So get a negative 12x plus 1 over 12 plus 24 over 12, which is 25 over 12. And that's it. Right, we still use y. Don't get confused with y or x, that's just variables. That's just variables. Right, you see this x and this x has nothing to do with each other, right? I just use them as representation. This x here is for this function placeholder, value holder. And this x here is just a value holder. So this x has nothing. They don't represent the same thing, all right? So you see the process is the same, but this one just give one more condition, perpendicular, combine tangent line to the curve. So that's why we have to combine two kinds of stuff into one. Anyone has any question? Okay, let's keep moving to 11. Okay, now again, we're asked to use a limit function. Limit function. Let me see if I can find. Maybe this is enough. Let me try to write it with the thin one. Oh, let's try to use this one. So remember the limit function is this. The limit definition. This is 2. Right. It's f prime of x equals to limit with the dummy variable h approaches 0. Then we have a fraction of f of x plus h. I don't need this. I don't need this parenthesis. Minus f of x divided by h, right? So basically we need to calculate. So we want to calculate f of x plus h first. So go to the function. So the function is this. So the input now is x plus h, right? So this function is saying square the input minus 2 times the input, then plus 4. So I follow the pattern. I square the input minus 2 times the input, I plus 4. Then I simplify this. So this is x plus h squared is x plus h times x plus h. So I get x squared, I get h squared, I get x times h twice. So I get x squared plus 2xh plus h squared. Then minus 2x minus 2h plus 4, right? So I multiply -2 with x, multiply -2 with h. Now that's f of x plus h. So I minus f of x. Well, minus f of x. What is f of x? F of x is x squared. So remember minus. Then a 2x. Then plus 4. You see these three terms just canceled, right? X squared minus x squared becomes 0. Negative 2x minus negative 2x becomes 0. 4 minus 4 becomes 0. So those just gone. So that means limit h approaches 0, f of x plus h minus f of x, what's left? That becomes only this term, these two terms, plus this term. So the difference is 2xh plus h squared minus 2h. Everyone has h in it. So that means I can factor out h. I'm left with 2x plus h minus 2. Right, so now let's write here. So I have h times 2x plus h minus 2. Now divided by h. You see, again, I have a common factor in the numerator and in the denominator. Right? H is the factor in the numerator, h in the denominator. H divided by h becomes 1. So now this is left with 2x plus h minus 2. Now I can plug in 0 for h. Right? Before I couldn't do that because h in the denominator. Now h only appears in the numerator. Only this h survived. So I plug in a 0. I'm left with 2x minus 2. 2x minus 2. Well, we could check use the power rule, right? We use the power rule. What's the derivative of f of x? Well, that's exactly 2x minus 2. But this is going through the definition of a derivative using the limit, right? Because that's the definition. This is a definition of derivative. It works for any kinds of function. But for polynomial-like, we could use something called a power rule as a shortcut. You could use the power rule to check, but in the test, you have to go through the definition to do this. All right? If you only use the power rule, you won't get credit. Anyone has any question? The calculation is pretty tedious. So make sure you can do that because there is one question on the exam. Okay, I'm going to erase this. Keep moving, all right? You can always go back to watch this. Now let's see, 12. Well, we want to find a prime of 1. So first we want to find f prime derivative. We use the power rule. 3x squared minus 4x plus 4. Then we plug in 1 for the derivative function. So 1 squared is 1, right? Like 4 times 1 is 1, so plus 4, get 3. And this is very simple, right? No one should have any problem with this. Well,
And
let's see,
just
13.
just
Yes,
a question, just like for the exam, like for what you did there, like that's all the work we would have to show for full
that's
credit. Like we
all
don't
the
have to.
work. Yes, that's all the work. Well, if you want, right, you can write one more step before this. Just write one more step saying 3 times 1 squared minus 4 times 1 plus 4. All right.
Thanks.
Okay, let's see 13. 13, we need a chain rule. So h prime of x. First, we're dealing with the power, 6. So 6 move forward. Then whatever inside, we write. Don't combine your steps. Don't skip your steps. Whatever inside, write it. Now 6 minus 1, this is 5. Then multiply the chain part. Take derivative of inside, which is 2x minus 3. All right, that's it. You don't need to simplify. That's all you have to write. So you have to take derivatives of twice. First, you take a derivative in terms of the exponent. You move 6 up front, you subtract 1 from the exponent. Whatever inside, you just rewrite it. Then you take derivative of the inside. Right? So this is composition functions. Okay, last one, we want to find the second derivative. So let's find the first derivative first. So f prime of x equals to a times 3 over 2, x raised by 3 over 2 minus 1 plus 2x. Well, simplify this. A divided by 2 is 4. 3 times 4, 12. X raised by 3 halves minus 1. 3 halves minus 2 over 2. Because 1 is always something divides itself. Right? We need a denominator to be 2, so we change 1 to be 2 over 2. Once we have a common denominator, we perform the operation in terms of the numerator. 3 minus 2, get 1, so half plus 2x. Now we find the second derivative, which means we take a derivative of the first derivative of 12 times half, x raised by half minus 1 plus 2. Then 12 times half, which is 6, half minus 1, half minus 2 over 2, negative half plus 2. Then we plug in 1. So f double prime of 1 equals 6 times 1 raised by negative half plus 2. Well, 1 raised by anything, 1 raised by any expression, still 1. So that's a 6 plus 2, which is 8. That's it. That's the last question. I think that's the last question. Oh, no, we have more. Okay, we do have more. How many more we have? Let me see. Oh, okay, we have a couple more. We have enough time, which is good. Okay, anyone has any questions? So 14, the problem is just the exponents, right? The exponents is a fraction. You just keep it because in the end you have to substitute 1 into it. Okay, let's see 15. Let me just show one more time of this. All right, that's for this. You can always come back for this. Now let's go to 15. 15 just to deal with the decimals and also understand one word. One word is the marginal profit. The marginal profit, which is the P prime. Right, equal to 0 0.002. 0 0.002 times 3 is 0 0.006. Then x squared minus 0 0.01 times 2 becomes 0 0.02. X plus 1.5. So the derivative function. And then given 10 units, because x represents the units, so that's p prime of 10. So 0 0.006 times 10 squared minus 0 0.02 times 10 plus 1.5. Well, 10 squared is 100. So 0 0.006 times 100. Well, 2 0 here, because the decimal point is here, right? You can add zeros. That's still 100. two zero before the decimal point will kill two places or enlarge. You can also think, well, you can use a calculator, right? You enlarge this number 100 times bigger. So that becomes 0.6. The minus is so 10 times bigger. So that becomes 0.2 plus 1.5. 0.6 minus 0.2, that's 0.4. 0.4 plus 1.5. Well, that's 1.9. And that's it. So the marginal profit is 1.9 for 10 units being produced. The trouble is a decimal, but use your calculator, okay? Let's see 16. So if the price in dollars of a profit is given this, right? And rational function, X represents the demand for the product. Find the rate of change of price. Again, we want to find a P prime of X. So just words, okay, marginal profit, because this is a profit function, means a derivative. Rate of change of price means a derivative. Right? So this function we can write as a P of X equals to 1024 X raised by -1. We want to write as a polynomial-like, so we can use the power rules. So that's so 1024 times -1 becomes a negative 1024. Then X raised by -1 minus 1, which is -2. Well, derivative of 700 is 0. So that's it. So this is our rate of change of the price. Then we're given 8 units. So we need to plug in 8. So that's negative 1024 times A raised by -2. Again, that's negative 1024 divided by A squared, or A squared is 64. That's negative 64, I think is so 1024. You can use a calculator. It's 2 raised by 8. And 64 is 2 raised by 6. Is that true? Oh, only 4? Let me see. So 1024 divided by 64. So this is 1, right? Minus 64, that's 8, 3, 84, 6, yeah, 6. Okay, 16. So equal to negative 16. Okay, so they're losing money, right? What does negative mean? Negative means they're losing money. Right? If they do not, if they only produce, if the demand is only 8 units, they're losing money. Okay, now let's see 17. A point P is moving along the x-axis. At any time t, the location of P on the x-axis is described by this. So position function. Position function. Don't care about the, the variables. Even x is here, right? You can think that's just a function. That's just x in terms of t. Just a function, just a variable, just a placeholder, okay? Don't be bothered by the variables. So determine the instantaneous acceleration. Instantaneous acceleration means is A. A is the derivative of velocity. Velocity is the derivative of, in this case, is x. Double derivative of x. So x Okay, or we can think the velocity equals to x prime. The acceleration equals to change of velocity equals to double derivative of x. So let's just, we need to just calculate. So let's find x prime. Again, it's just a variable, okay? Don't be bothered by the variable. But usually we do not use x to represent a function. But however, you know, so we get 3t squared minus at plus 3, right? First derivative. Or second derivative, 6t minus 8, right? Now we're given time equals 5. So we just have to plug in 5. 6 times 5 minus 8. So 30 minus 8, which is 22. So the acceleration at time 5 is 22. We don't know the units. That's okay. And that's it. So first, do not be bothered by the variable x. You just think this as function of t, all right? Function of t. And acceleration, just a double derivative in terms of t. Velocity is a derivative of the function. Anyone has any question? Okay. I'll keep moving. Okay, determine the value k that makes the function continuous. Continuous means function is connected, right? No holes, no jumps. So, which means the function value at 0 here for this one. So when so this is this is called piecewise function. Kx squared plus a at 0. When we evaluate x equals 0, it has to be 3 plus x evaluate when x equals 0. Well, when x equals 0, this one we get a k times 8, which is ak. Right? When x equals 0, this side is 3. So solve for k, just 3 divided by 8. That's it. Right? Continuous means add the because 0 is different, right? So this is x equals 0. Right? When x greater than 0, the function is defined as a parabola, degree 2. When x less than 0 is defined as, what do you call it? Line, straight line, right? So this is line, this is parabola. So at 0, they have to meet. So which means they have to have the same point. It has to be 0. Right? They have to meet at this point. So that's why we just plug in 0 for x for this, and this have to equal each other. Of course, this doesn't have to be 0, right? This can be any number. Let me use another number. I could change this number to be any number I want. I would probably say 1. 1. So what do we do? That means k times x squared plus a when x equals 1 has to equal to 3 plus x. X equals 1, right? Because at 1, the function acts differently. You know, the left-hand side acts one way, the right-hand side acts another way. So if we want the function to be continuous, they have to meet. They have to have the same value at the same point, x value. So then we just solve. So we get k times 9, which is 9k equals to 4. So k equals 4/9, right? So on and so forth. So this can be any number. This can be any number. Okay, now let's see. 19. 19, we're given this graph. We see this one, you see the line breaks, right? So this is -2. So not continuous. So function is not continuous at x equals -2. So we only want the x value, right? So when x equals -2, you see the function breaks. We indicate with an open circle. B, derivative does not exist. Remember sharp point. What's the value of x? 2. So x equals +2, the derivative doesn't exist. Remember what's the derivative? Derivative is the slope of the tangent line. So one way, at this point, we could draw this slope this way, because both are straight lines. And another way, so we have two slopes, right? So which one to follow? So we see does not exist, right? If it's not unique, we just say does not exist. Any questions? So for any cups, so if the function acts this way, at this point also not differentiable. So derivative does not exist. Or we say at this point, at x equals -2, the function is not differentiable. $20, I think, is the last question. So 20 also we want to state x value, right? So function is not continuous, give reasons. Continuous but not differentiable, right? Use this word differentiable means the derivative does not exist. Well, at x value equals -3, right? We see the jumps. We see the jumps. If you really have to be mathematically right, you see this. The limit of x approaches to -3 from the left-hand side, remember we indicated with the negative, of the function, we do not know the function, we just use f of x to represent, does not exist. Oh, no, not does not exist. So we're talking about the left-hand side. You know, left-hand side limits for any point always exist. Or left limit, right limit always exist. So which value approach to? Let's see this value, right? So we don't know exact value, so maybe let's mark with A. Maybe you mark this with B. So we say then we write A, write B, we say this equals to A. The left limit equals A. Well, then what's the right limit? X approaches -3 from the right-hand side. That equals to B, or equals function value, f of -3. So that's why it's not continuous. But remember, continuous means the limit of x approaches to a value of a function equals to the function value. Right? That means function is continuous. So they do not equal to each other. The left limit and right limit do not equal. So which means the limit, this one does not exist. If it does not exist, right? Of course, we see pictorially, we see this jump. We see this big jump. From the left-hand side is here. From the right-hand side is here. So at the same point, there's a jump. So that's the reason. Okay, now at the point x equals 1. So the answer for this one is x equals 1. You could use your pen to draw. So one way, at this point, we can draw a tangent function, right? Tangent line. And we can draw another tangent line from the left-hand side. This is from the right-hand side. Well, from the left-hand side, it goes this way, right? The two tangent lines at this same point for the graph. Imagine this is our f of x, right? So this line represents a function. these curves represents one function. That's how this function behaves in the picture wise. And so this point called a cusp. So at 1 called a cusp. So this point called a cusp. All right. In this cusp, from the left hand side, we can draw a tangent line this way. From the right hand side, we can draw a tangent line this way. So that's why it's not differentiable, because it's not unique. We have two to follow. So which one will follow? It's like telling people, I'm 20 years old, I'm 21 years old. So which one is your age? Right? It has to be unique. Any questions? Okay, some of you are late. You can I recorded this, so I'm going to put in an announcement so you can you can watch. Anyone has any questions? So if the weather permits, so our exam will be postponed to Wednesday. If Wednesday is still as bad, if the campus is still closed, we just keep pushing forward. All right. Hopefully Wednesday is better. So if Wednesday the campus is open, it's going to be our first exam date. Anyone has any question?
No questions. But did you take attendance?
I'm going to.
Okay.
Yeah, I'm going to. So let me just erase this and close this. So I'm going to take a picture of the attendance so I know who is here, who's not. Mm. Mhm. So I hope every one of you feel confident for the first exam. It seems like I was told the passing rate for this course is really low, but I would do whatever it takes to help you to pass this course. Let me stop recording. Okay, I have pictures. I'm going to check attendance later. If you don't have questions, you are free bird. If you still have questions, you can stay behind. Talk to me, okay?